Hello and welcome to this episode of Microchips, and on the bench today we have this Labgear frequency counter that is very similar to the Pi frequency counter that I got a while ago. I got this nice and cheap off eBay, supposedly not working, so let's see if we can fix it. But before we start, don't forget to like, share, subscribe, comment, join the Facebook group, join Patreon, buy me a coffee, all that lot, have a look at my website. And now a word about today's video sponsor, PCBWay. PCBWay is a China Shenzhen based PCB manufacturer and printed board assembler with more than a decade in the field of PCB prototype and fabrication. They offer a wide range of services including 3D printing, CNC machining, sheet metal fabrication and much more. PCBWay also offer a prototype PCB assembly service with component sourcing and online quote with 24-hour delivery services. PCBWay is committed to meeting all of your PCB needs. They offer quality, on-time delivery and competitive pricing. 1 to 2 layer boards start at $5 with 24-hour turnaround. Get an instant quote by visiting PCBWay.com or click on the link below to check them out. So thank you PCBWay for sponsoring today's video. And now on with the show. So here's the Labgear frequency counter. I do like these frequency counters because of that unique LED display that's in them, and that's what drew me to it. Plus I like old equipment, I like old counters. So it's not in bad condition, it's got a few war wounds, but you know, I expect this to be at least 40-year-old. So it's still got its original push button on the side, so I suppose that was just so you didn't leave it switched on and drain the batteries. I will be converting that to a normal switch. And let's have a look inside. So unlike the Pi counter that I got, this one's actually got a battery pack in it, but I suspect that it's crusty. And yes, it's most definitely crusty. So I'm wondering if that is just the fault. Have we got a dodgy battery pack, or have we got something else going on? Having a look at the circuit board, everything looks nice in there. Luckily the batteries haven't leaked their goodness over it, and generally inside is a lot less worked on than the Pi counter that I have also got. But yeah, that's definitely crusty. That's definitely going to have to come out. So let's open up this battery pack and yeah, I think they possibly have been changed before, probably many times in its life, but as with all NiCads, I suppose these are NiCads, yeah, they've rotted and corroded, so we're going to have to take those out and see whether we can't get this unit powered up. So just out of interest, just having a look, see if there's any voltage on the batteries, and as suspected, they're stone cold dead. So let's remove them and let's feed some voltage in and see what happens. So with there being 4 cells, 1.2 volts, we'll put 5 volts in and see what happens. So I've got 5 volts on my bench supply. Just checking for any immediate shorts. I've got it on current limiting, so there's no immediate short. So we'll turn it over, push the button, and we get one segment, and it doesn't seem to do anything else apart from the single segment. And no matter what we do, it does not change. So it looks like we've got a fault, and the question is, can we fix it, and can we find the spare parts for it? That's going to be the next big issue. So let's have a look. So inside the unit we have 2 main ICs. We have the display controller, which is the CM7044. And looking at the datasheet for it, it does give us a basic schematic diagram, which is very handy. We've also got yeah, some very interesting information on this. So if we scroll down the data sheet, we can see more complex schematics, and this one where it uses its counterpart IC, the 7207. Now, I'm not sure which one of these ICs it's going to be, but for me, I think the display driver is working. And we've got these timings as well. We've got strobe reset and counter enable. So just remember those, because they're going to be very important in a moment. So let's have a look at the CM7044, this CMOS time-based generator, which is its counterpart IC. Now this IC provides the reset, the counter enable and the strobe, and also the crystal timings as well. And there's our timings again. So something is very important with these strobe reset and the gating output or the counter output. So I did a little bit of measuring around this IC, and on the crystal we should have had this, but I had nothing, so the crystal was not oscillating. So if the crystal's not oscillating, then there can be no timings. Now let's have a look at the counter enable. So on the counter enable you can see it's flicking between on and off, but this was not happening. It was just off, so I had no clock and it was not going off. So I changed the chip, I took it out of my Pi unit and it sprung to life, and there's those beautiful LEDs in all of their glory. So we know what's wrong with it. It's that 7207 time-based IC. Question is, can I find a replacement? Because this must be 40+ year old. I tried to get a close-up of these LEDs, but unfortunately I couldn't, but they're beautiful. So there's the chip, ICM7207 AIPD, made by Intersil. And I took it out of my Pi unit. It was a case of, do I take the display driver out, or do I take this time base? And because I was getting no crystal, I was getting no resets, I was getting no counter enables, I went for this, and we struck gold straight away. So what I'm going to do is I'm going to give it a bit of a clean up, and I'm going to fit a switch to the side of it, and we're going to fit a new battery pack. So I've cleaned up the front glass, used a bit of polywatch on it, it's made it nice and shiny. So I've got my GPS reference, got it set to 25 megahertz. Let's see whether it actually reads and counts. So I'll push in a button on the side, and yeah, we're close. Just needs a quick adjustment. That's easily done through the adjustments on the bottom. There's one for the 50 and one for the 500, and there we go, bang on 30 megahertz. So this unit is working. Now there is a little bit of damage to one of the LEDs just in the middle. You may notice it's a bit dimmer. Who knows why that's happened? Has it been overvolted in its time, or is it just, you know, I don't know. But there's the 500 megahertz range, bang on 30 megahertz. Beautiful. So I'm going to be taking this socket out, which obviously must have been used to charge it, and I've taken out the push switch because I like to have a flick switch on it. I can see why they put a push switch on it, just so you could do a quick test, and then, you know, you don't accidentally leave it switched on, and, you know, when you throw it in your toolbox or your tool bag or something. But that's not going to happen to this unit. It's going to sit on my shelf, and I will switch it on and off when I need it. So I've fitted a barrel socket in place, just had to drill it out a little bit. Put some extra wires. So we've got a battery pack there, made out of 4 1.2 volt nickel metal hydrides. We put it back in, and it's looking very nice. So we'll put it all back together. Got it back on my GPS reference, and yeah, it's looking good. It's looking very good. But we still have a problem. We've still got a faulty unit, because now I've transferred the fault over to the Pi unit. Or shall we say we've removed the faulty part from my Pi counter, which is essentially the same, just with Pi written on it, but it does actually say Labgear on the sticker inside, so yeah, they are pretty much the same.
2 weeks later.
So after a lot of searching round on the interweb, we find a replacement. Now it looks nothing like this chip, so I'm just hoping it's not a fake, but it's got the same markings on it, doesn't say Intersil on it. So I'll put it into the counter and we'll solder it up. Just like so. There we go, nicely soldered in place. And will it work? And luckily enough, as you can see, we have all the zeros, so for me that's working. So I've got it connected up to my reference, and we'll adjust the bottom adjustment, and as you can see, we're now reading 10 megahertz. That's what the reference is set to at the moment. Fantastic. So we've got the Pi unit working again. So there we have it, a pair of frequency counters. I didn't actually think I'd see another one that looked like the Pi one again, and there's certainly no information on the internet about these, but luckily with the data sheet and finding that IC on the internet, we were able to fix it and we were able to bring it back to life again. So like I say, I do like these counters because of that unique LED display. I think it gives it a beautiful retro look. But anyway, that's it for this video. Don't forget to like, share, subscribe, comment, join the Facebook group, join Patreon, buy me a coffee, have a look at my website, microchips.net. Big thanks as always to PCBWay for sponsoring the video. And thanks for watching, and we'll see you in the next video.